In today's video, we are going to practice a linear programming problem. And so let's see what it says. Manufacturing. A backpack manufacturer produces an internal frame pack and an external frame pack. Let X represent the number of internal frame packs produced in an hour, and let Y represent the number of external frame packs produced in an hour. Then the inequalities X plus 3Y is less than or equal to 18, 2x plus y is less than or equal to 16, x is greater than or equal to 0, and y is greater than or equal to 0, describe the constraints for manufacturing both packs. Use the profit function f of x equals 50x plus 80y and the constraints given to determine the maximum profit for manufacturing both backpacks for the given constraints. Well, let's take a look at the first inequality they give us. We have x plus 3y is less than or equal to 18. This inequality is given to us in standard form, and so the best way that we've seen in the past to graph inequalities in standard form is to find both the x and y intercepts. So let's make ourselves a table. And so our y-intercept is going to be when x is equal to 0. So let's plug that in. So when x is equal to 0, we have 0 plus 3y is less than or equal to 18. Well, 3y is less than or equal to 18. That's the same thing. And we need to get y by itself. So let's divide both sides by 3. The 3's on the left are going to cancel each other out, and we will be left with y is less than or equal to 6. So we can plug 6 into our table. What about our x-intercept? Well, that's going to be when we have y equal to 0. So let's plug that one in. So we have x plus 3 multiplied by 0 is less than or equal to 18. 3 times 0 is 0, so we're left with x is less than or equal to 18. So we can plug 18 into our table. Now we have 2 points that we can graph onto our coordinate grid so that we can draw in our line. So 0, 6, we have to go across 0 and up 6. So 1, 2, 3, 4, 5, 6. But wait, we won't be able to fit 18 if we count by 1s, so we need to count by 2s on our x and y axis. So this is going to be 2, 4, 6, 8, 10, 12, 14, 16, 18. And on our x-axis, 2, 4, 6, 8, 10, 12, 14, 16, and 18. So now if we go up to 0, 6, we'll be right here. And 18, 0 is all the way down here on the x-axis. We can connect those 2 points with a solid line because less than or equal to means we have to have a solid line. And so we need to shade in everything that is below that line because less than means everything that is less than that. For our second inequality, we have 2x plus y is less than or equal to 16. Again, this one is given to us in standard form, so we want to make this table again with our x and y intercepts. So we have our x and our y. And so our y-intercept is when x is equal to 0. So let's plug 0 in for x. 2 times 0 plus y is less than or equal to 16. 2 times 0 is 0, so we're left with y is less than or equal to 16. So we can take that 16 and plug it into our table. And our x-intercept is going to be when y equals 0. So let's plug that one in as well. 2x plus 0 is less than or equal to 16. Well, 2x is less than or equal to 16. That's the same thing. And we need to get x by itself, so let's divide both sides by 2. So these two are going to cancel each other out, and we will be left with x is less than or equal to 8. So let's plug 8 into our table. Again, we have 2 points now that we can put onto our coordinate grid. So we're going to have to go up 16 and put our point up here. We have to go across 8 to get our x-intercept. So we go all the way to 8. And then we got to connect our points with a solid line because we have a less than or equal to sign. And again, since we have a less than or equal to sign, we have to shade in the area below that line to get our possible answer. So anything below there. What about our next inequality? X is greater than or equal to 0. We've seen this one before, and so we need to find the x value of 0. So that's going to be over here, and again we need to draw in a solid line because it is greater than or equal to. So if we draw in a solid line at x equals 0, it's going to be right on our y-axis. We are going to have to shade in a certain region. Well, if x is greater than or equal to 0, it's going to be anything that's bigger, so anything that is to the right. And finally, we have the inequality y is greater than or equal to 0, so we have to find our 0 value on the y-axis, which is again right here, and we are going to draw in a solid line at that point. And we're going to have to shade in a certain part, and since y is greater than or equal to 0, we have to shade in anything above that line. So right now we've got a ton of colors drawn into our graph, but the only part that we are worried about when we are drawing in all of these inequalities is the part where all 4 colors overlap. So that is going to be in this little quadrilateral over here. And so, like we have done in the past, we need to find the coordinates of the points of that quadrilateral. So I'm going to call this one over here point A, this is point B, point C, and point D. So let's find our points. Point A is going to be left or right 0, so that's our x value, and we have to go all the way up to positive 6. Point B, we had to go to the right 6, so positive 6, and we had to go up 4, so that's our y value. For point C, we had to go all the way to the right 8, and we didn't go up or down at all, so that's going to be 0. And finally for point D, we didn't move at all from the origin, so we're going to be at point 0, 0. The next step in linear programming problems is to take all of those points and plug them into the equation that they gave us. So 50x plus 80y. And since they want us to find the maximum profit, we want to look for the number that is going to give us the highest number, the point that's going to give us the highest number. So let's go ahead and plug in point A. So if I plug in 0, 6 in for my x and y, I'm going to get 50 multiplied by 0 plus 80 multiplied by 6. So 50 times 0 is 0, plus 80 times 6, which is 480. So 0 plus 480 is 480. What about point B? We have to do 50 multiplied by our x value, which is 6, add 80 multiplied by our y value, which is 4, and so 50 multiplied by 6 gives us 300, and 80 multiplied by 4 gives us 320. So 300 plus 320 gives us 620 total. What about point C? We're going to have 50 multiplied by our x value, which was 8, plus 80 multiplied by our y value, which is 0. So 50 multiplied by 8 gives us 400, but 80 times 0 is just 0. So all we have is 400. And finally, point D, well, this one's going to be exciting. 50 multiplied by 0 plus 80 multiplied by 0 gives us 0 plus 0, which is just 0. So since we're maximizing our function, we want to look for the number, the point, that is going to give us the highest number. Well, out of all of these, I'm pretty sure 620 is the highest. So point B is going to be our answer. So that means we are going to be making 6, well, what was the x representing? Well, x represents the number of internal frame packs. So we're going to have 6 internal packs, and we're going to have 4 external packs. And if we make 6 internal and 4 external, that means we are going to get the most money for our products.